Um, I just want to take a minute and thank you and introduce a little bit about what we're going to do, and then turn it over to the people who are actually the experts at what has happened here. But this is a big closure for us. You know, we came and responded to Tub Canyon, who was asking for our help in looking at how water works in the desert and how plants use water in the desert a couple of years ago, and brought to us this problem of thinking about the aquifer in Borrego and how it influenced ecosystems on the land surface. And it is a great problem. If you're a scientist, you think about problems, you know, no matter how terrible they are, they can be exciting and fun to study. And this is one of those ones that, even though it's got some sad sides to it, it was a challenge and it was fun to do as a scientist. So we've spent the last couple of years spending time in the sink and Clark Dry Lake bed and doing lots of science. I haven't gotten in these guys' way too much, which has been my challenge. And we're very excited about what has been done. I've done work like this for a long time. And usually when I do projects, we carry them out, we write some paper that goes in some academic journal that like 4 people in the world read. and I feel good about that. And so this has been a very different project because we have done this in a very open science framework. You know, from the first day that we collected data or did some analysis, we were immediately bringing it to the community to consider. And I think that was really important. I mean, I grew as a person because of it. And I think these guys probably learned a lot about doing science in that way too. And so in some ways, this is incredibly meaningful because we've spent time collecting data that will affect how you make decisions about your community. And that's like more than we could ask to do. That's satisfying. So I am going to turn it over to these guys who are going to talk about the groundwater dependent ecosystem in Borrego Valley, and they can do a better job summarizing the science and the issues than I can. But I just want to say, you know, these two are exceptional. And I think that any of you have been around for a couple of years, I hope you've watched them through a really unique period in their career when they went from being PhD trainees, and I mean, they had their PhDs, but they really blossomed as professional scientists. And we've got to watch them do it in the last 2 years, which has been very exciting. And you guys have just done a fantastic job. This is an amazing project, and you should be really happy with what the effort you put into it. So thanks. All right.
Okay, we're going to do a quick mic check. Can you hear me at all with this? Good. Do you want to do a mic check?
Testing. Sounding
All
good?
good? Louder?
It's as high as it goes. So we will just talk louder.
Is this loud?
Y'all have hearing aids.
It goes down there. Can you tell us your name again?
Yes. Oh, how's that? That's better. All right. I'm Nikki Fiore. Oh, too loud?
No.
Oh, okay. Well, go ahead and go to this slide. So my name is Nikki Fiore. I am one of the project managers and researchers from the UCI team, along with Laurel Brigham. You just heard Travis Hussman talk. We have our UC Irvine Masters capstone team here in the front row. You'll get to meet them today. We also have some great project partners at Tub Canyon Desert Conservancy who are here today. And we also have partners from the San Diego Natural History Museum. So the format for the night is, of course, this presentation. Then we'll have a poster session and we'll have time for snacks, beverages, and conversations with the research team. So our project objective, of course, was to determine whether the mesquite bosque near the Borrego sink was a groundwater dependent ecosystem, or GDE, and thus must be considered as a beneficial user of groundwater under SGMA, which is the Sustainable Groundwater Management Act. So GDEs are defined under SGMA as ecological communities or species that depend on groundwater emerging from the aquifer or from groundwater near the surface. So our project uses the guiding framework established by the Nature Conservancy and the Sigma guidance for identifying, monitoring, and managing GDEs. I've included the link down here at the bottom and their lovely flow chart, which announces their steps for identifying, managing, and monitoring GDEs. And our project focuses on steps 1 and 2, which are to identify the GDE and characterize its condition, and then to determine any potential adverse effects on the GDE. Now, steps 3 through 5 are really meant for the stakeholders like the water master and the subbasin. And our project really focuses on providing the best available science to help these critical management steps in steps 3 through 5. And our project uses a functional approach that combines remote sensing, field data, laboratory methods to identify GDE mesquite and assess their health and water use patterns. And this aerial photo is from one of our sites, Site 1 near the Borrego Sink, just south of Borrego Sink. As you can see, the mesquite health varies quite drastically across the landscape. So the overview for our topics for tonight are, first, we're going to talk about identifying the GDE. We'll then move on to characterization of the GDE and potential adverse impacts to the GDE. And then we'll go over some of our management recommendations. So this table we'll be going through tonight, and it'll just summarize some of our different results for how we determined the mesquite bosque near the Borrego Sink was in fact the GDE. So our first question or topic is groundwater or the capillary fringe present within the rooting depth of any known phreatophytic vegetation? And phreatophytic vegetation is any plant that is known to use groundwater, like mesquite. So to identify the GDE, we used image classification of high resolution native imagery to identify 1,850 acres of mesquite bosque habitat found in the central and south management areas. And it's shown there in the map in lime green. And then we use groundwater elevation and topography data to map the depth to groundwater, which is shown here in this map in blue. And as you can see, let me grab my pointer. Here we go. Near the Borrego Sink, you can see that groundwater is quite close to the surface. So it's as shallow as 18 feet below ground surface at the most shallow point. And if we overlay that 1,850 mesquite bosque habitat on top of this map, you can see that mesquite are found where the depth to groundwater is predicted to be within 22 to 134 feet below ground surface. And mesquite are known to have some of the deepest roots in the world. And they have been documented to have rooting depths that can extend from 39 to 175 feet below the ground. So all of the mesquite near the Borrego Sink are within reach of groundwater, which supports their classification as a GDE under Sigma. So to answer our first question on the table, we can say yes, 1,850 acres of mesquite bosque habitat are found near the Borrego Sink, where groundwater depths are within 22 to 135 feet below the ground surface.
Wonderful. So across this mapped area, we established 5 different sites. So thank you. So we established 4 sites in the vicinity of the Borrego Sink. We additionally established 1 site near Clark Dry Lake, which is in a different basin and is not subjected to overpumping and serves as a comparison where there is healthy groundwater dependent mesquite. So here we asked, does isotope source indicate the use of groundwater across these trees? So we have some isotope data here for you. We have on the vertical axis an indicator of isotopic composition. On the x-axis here, we have those different sites 1 through 5. We present site 5, that Clark Dry Lake, abbreviated here as CDL, our comparison site, as the first, and then sites 1 through 4 are adjacent to that. You'll see some different sources here. So we've got soil water, mesquite tissue water, and well water as our different comparisons. And we did this sampling at 3 different time points across 2 years. And what I want to highlight here is that this green X, this is the mesquite tissue, that it is indicating a mixed water source. So it is not overlapping with the soil water source, which would indicate the use of surface water only. It's not overlapping with the well water, indicating groundwater only. It is indicating that it uses both groundwater and surface water. So in summary, yes, there were 48 trees across those 4 sites in the vicinity of the Borrego sink, and across both years, these data indicate groundwater use by these mesquite trees. We're next going to move on to some plant-water relations. So we're going to be looking at pre-dawn and midday leaf water potential. We're going to be comparing between phreatophytic vegetation, which, as Nikki mentioned, is vegetation that can use groundwater, and a non-phreatophyte, which cannot. So briefly, just an introduction to leaf water potential. So pre-dawn leaf water potential is measured between around 3 to 5 a.m. And what this gives you is a baseline indication of water availability. So here, Nikki and I are around 3 a.m. I think this is at Clark Dry Lake, collecting leaves for leaf water potential. And then you have to go out at midday. So this is around 11 to 1, the middle of the day. And this is an indicator of water stress. So just to note, if you have a more negative value, that is indicative of lower water availability when thinking about pre-dawn water potential, or greater water stress if thinking about midday water potential. And as I mentioned, we compared a non-phreatophyte, so we used creosote because it was highly abundant at both sites. And this is a shallow-rooted species that's known not to access groundwater. And then, of course, we compared it to mesquite. And what we found, I've just highlighted this here in bold, is that creosote always had those more negative values compared to the mesquite, which is indicative of lower water availability and greater water stress compared to the mesquite. So in summary, yes, this indicator gave us further proof that the mesquite bosque is indeed groundwater dependent, because all of the mesquite had higher water availability and lower water stress than creosote that was just a couple meters away. Now we'll move on to some remote sensing approaches.
So our next section on this table is our remote sensing approaches. So we designed 3 different remote sensing approaches, which are shown here. The first 2 really focus on identifying vegetation that maintains its green biomass or increases its green biomass during extended dry periods, which indicates that it's using groundwater. And the third approach really looks at finding abnormally high productivity or abnormally green vegetation compared to other non-GDE areas. So we designed those 3 remote sensing approaches, and when we combined them into one single map, which you can see here, we found widespread indications of mesquite groundwater use throughout the entire habitat, which confirms groundwater use. So in this map here, this is the mesquite bosque habitat near the sink, and every single point there shown in green. Let me find my pointer. So all of these points shown in green are mesquite that showed signs of GDE behavior in 2024. As you can see, they're found throughout the entire habitat. But you'll notice the strongest green is really around the Borrego sink, where groundwater is closer to the surface. So this is a really good sign that all of these trees are accessing groundwater. So back to our table. Yes, hundreds of acres of mesquite canopy in the map mesquite bosque habitat shows signs of GDE behavior for the different approaches for both 2023 and 2024. And our final topic in this table is a water balance or evapotranspiration method. So our question here is, are plant transpiration rates during extended dry periods consistently greater than 0, which would indicate groundwater access? So to determine this or measure it, we installed state-of-the-art light or evapotranspiration sensors, or ET sensors, in our different mesquite habitats at sites 1, 2, and 4, which are in Borrego Springs around the sink. And then, of course, we established one at our site 5 in Clark Dry Lake as our comparison site. And these ET sensors directly measure evapotranspiration at 30-minute intervals. So these are some of the newest, highest tech, and affordable evapotranspiration sensors that can give you real-time data on water in ecosystems. So GDEs will continue to transpire water throughout extended dry periods due to their groundwater access, whereas an area that does not have groundwater access will not transpire any water because there's no water in the ecosystem. So when we installed these ET sensors in May 2024, it was an extremely dry year, as you all know. It's one of the driest years in a very long time. So only 6 millimeters, which is about 1/4 of an inch of rainfall, fell during our ET sensor deployment period, which is this orange box here. And that's our 1/4 inch of rain that happened during that time period. So not a lot of water. And 2024, the entire water year was also a very dry year. That was a dry winter. And as you can see, not a lot of rainfall. So over the entire water year, we only had about 3 inches of rainfall. So this was a really good opportunity to track groundwater use because there was no other water in the system during that ET sensor deployment period. And as you can see here in this figure, all of our mesquite sites displayed consistent and sustained ET across the dry growing period, confirming groundwater use. So these are our sites at the Borrego Sink, site 1, 2, and 4. And this is Quag Tri Lake. And you can see that they all have positive ET above 0 during the entire dry growing period. There was no rainfall except that 6 millimeters. So in a single month, they are transpiring far more water than was entered in with precipitation. So that's a good sign of groundwater use. Another way to look at this is to do the cumulative ET, which is adding up the ET over time, which is shown here in green. And we compare it with the total precipitation for that same time frame, which is our blue dotted line here, which is just above 0, that's 6 millimeters. And as you can see, all of our mesquite bosque sites greatly exceeded the amount of precipitation that fell, which confirms consistent groundwater access because there is just nonstop water coming from this mesquite, despite there being no rainfall. So coming back to our last point in our table, yes, ET was consistently above 0 for the dry period in 2024 at all of our mesquite habitat sites near the Borrego Sink. So a quick summary of our evidence. All mapped acreage, which is 1,850 acres of mesquite bosque habitat, should be considered a GDE. And that's because the depth to groundwater across this area indicates that the mesquite can indeed access the groundwater at that depth. Our isotope data also indicates that they are using groundwater throughout the year in both years. Our remote sensing data confirms GDE behavior at all of these trees. And our ET sensors, again, confirm groundwater use throughout the entire growing season. So now we're going to move on to our characterization of GDEs and potential adverse impacts to GDEs. So I'm going to take a moment to introduce our capstone team, who will do a little bit about their work to characterize wildlife and biodiversity.
Hello, we're graduate students at UCI in the Masters in Conservation and Restoration program. And we've been working on the Mesquite Bosque Health Capstone project as part of the larger GDE project. One component of our work was creating a species inventory to document biodiversity at the bosque. We made this using data from our own field research, the San Diego Natural History Museum, and participatory science data.
One of the other data sources that went into the species inventory was wildlife cameras, which you might also know by the name of trail cams or camera traps. We process that data using Wildlife Insights. And then we also are working on a trophic level study, studying insects and arachnids, and then also looking at birds. So we're looking at if the mesquite is supporting insects and if that's supporting birds and the trophic interactions there.
With that camera trap data, we actually had the privilege to have local Borrego Spring High School students have access to that. and they were able to make their own scientific inferences about the wildlife here in Borrego Springs.
And as a result of all of these efforts, we were able to create a monitoring plan for the mesquite bosques of Borrego Springs. This document will help inform future monitors of the best techniques and practices to monitor any threats to the biodiversity of the bosques. And this will allow them to determine ways to remedy this before there are any lasting negative impacts.
And finally, we're all going to be presenting with our posters in the back after the presentation. So if you have questions or you want to know more about any of these components, feel free to come talk to us. Thank you.
Great, thank you so much. As a result of the species inventory that the students conducted, and also building on some of the work that last year's capstone team did as well, we have documented 276 animal or fungus subspecies, species, or genera within the mesquite habitat near the Borrego Sink, 120 within the habitat near Clark Dry Lake. And I think this is really key to note that there are only 30 overlapping species between these two habitats. So it's an incredible amount of really unique biodiversity across these two sites. And then of course, a total of 43 at-risk species between these two areas. So really, really impressive work that these capstone teams have worked on. I also want to highlight the work done by the San Diego Natural History Museum, and a huge shout out to Daniel Donovan, who is with us today. Thank you, Dan. So, sure, absolutely. He deserves it. He's been walking all around the mesquite habitat documenting its flora biodiversity. So as a result of these efforts, we have found 142 native plant species within the mesquite habitat near the Borrego Sink, 176 near Clark Dry Lake, and 9 of which across these two sites are threatened, endangered, or rare. And one particularly cool thing that I just want to highlight is Johnstonella angelica here. So this is only the second time that this species has been observed in the US. The very first time was actually in 2019, right here. And Dan has that specimen in the back. So please go and visit him and check that out because it is very cool. And this was near Clark Dry Lake. So in terms of biodiversity, we recommend continued monitoring in order to better understand and track the biodiversity of this really important and critical habitat. And I just want to promote that the capstone students put together a very lengthy monitoring plan that you can find in the report that we have put together. So please do give that a read. A lot of work went into that. All right, shifting gears from biodiversity now to characterizing the GDE from a different angle. So taking a look at groundwater levels. So we would really like to advocate for data-based minimum thresholds to be developed. So we've done, let's say, a thought experiment for you to define a minimum threshold using a different kind, a couple of different windows of time. So here, this is the period from 1953 to 1963. So this is some of the earliest available well data in Borrego Springs. And we summarized across the different water years, the different levels of groundwater that we're seeing. So the most shallow groundwater that was detected across this time period was only 5 feet below the ground surface. And these are all wells near the Borrego Sink. The average was about 25.5 feet. And then the maximum depth, the deepest depth that we detected across that time period was about 59.6 feet below ground surface. So using a data set like that across this early window of time, you might suggest a minimum threshold of around 59.6 feet below ground surface. So here's where the second part of the thought experiment comes in. Let's say you used a different window of time. Let's say it was 2005 to 2015. Instead of 5.3 feet below ground surface as the shallowest well depth, you might get 49.4, an average of 69.5, and the deepest of 102.8. It is important to note that these are different wells between these two time periods because there's not overlap actually in between the wells that are active in that early period and then active during this later period. but they are all in the same locale. So very important to understand that when you're establishing a minimum threshold, that you're using the appropriate data so that you are setting a minimum threshold based on a healthy baseline rather than an unhealthy baseline. And I just want to point out a couple of example wells. This is MW3 here. And between the time period of the mid-2000s to now, it's seen about a 20-foot decline per decade. As of October 28th of last year, it was sitting at 78.6 feet below ground surface. And then this well up here is the MW5A and B well. It is declining about 5.5 feet per decade across that same time period and was last sitting at 58.8 feet below ground surface. So we recommend higher resolution groundwater depth rasters. So this is related to the data set that Nikki was talking to you about earlier with those different blue tones across the basin, where she showed you that groundwater can be within 18 feet of the ground surface in the vicinity of the sink. So we need better data of that kind and more frequent monitoring of the spatial trends in that groundwater depth. Because it's very likely that this is site 1, and these little points here in green are the tagged trees that we have been monitoring for isotopes and water potential. It's very likely that the depth to groundwater here is not 58.8 feet below the ground surface. Based on the groundwater raster depth data, it's closer to 20. So we need those data to better inform the management of this system. In addition, because it is highly valuable, we recommend continued monitoring of key wells, and we recommend establishing data-based minimum thresholds.
Establish that groundwater has indeed been declining quite rapidly around the Borrego sink. I'm going to talk a little bit about characterizing the mesquite bosquet's health and productivity. So we used high-resolution remote sensing to create a baseline assessment of mesquite bosque health and productivity. And I use the Sentinel dataset here, which is a 10-meter resolution, which is fairly high resolution, which means you get a very clear view of a mesquite tree or a patch of mesquite trees. And when we apply this method in 2024, we can see that the Borrego Springs mesquite bosque habitat has about 82 acres of high productivity vegetation, which is shown here in the darkest green down here. We have about 590 acres of moderate productivity, which is in the medium green down here. And we have about 1,500 acres of low productivity habitat. So again, looking at this map here, we can identify exactly where mesquite are moderate to high productivity, which indicates high health. And you'll notice that the darkest green is around the Borrego sink, where groundwater is closer to the surface. So we know in total there's about 670 acres of moderate to high productivity mesquite. And these type of mesquite provide really valuable ecosystem services to the Borrego community, such as critical wildlife habitat for all of that biodiversity we documented. This woody habitat also provides a lot of carbon sequestration, and it's one of the only large-scale widespread woody habitats in all of Borrego Springs, so this is really important. The mesquite also provides soil stabilization because they have incredibly deep roots that help keep the soil there so it won't erode as quickly. And they provide microclimate cooling due to all of that water that comes off the mesquite. So that provides a cooling effect when you're in mesquite bosque and quite a bit of shade for wildlife and other biodiversity. So we can apply this approach going back in time, and this data set starts at the end of 2018. So we went all the way back to the 2019 water year, and we tracked the high, moderate, and low productivity at the Borrego Springs mesquite bosque, shown in yellow, and at Clark Dry Lake, shown in dark blue there. So in this top graph, you can see that the mesquite bosque in Borrego Springs recently contained similar amounts of high productivity to the mesquite at Clark Dry Lake. So as early as 2019, which is fairly recent, there was quite a bit of high productivity mesquite in the Borrego Sink area, and more of it than there was at Clark Dry Lake. You also notice that the Borrego Springs mesquite bosque contains more moderate productivity vegetation and low productivity vegetation than Clark Dry Lake, and that's largely due to its size. The Borrego Springs mesquite bosque is almost 10 times as large as the Clark Dry Lake mesquite bosque. And there's quite a bit more of a range of groundwater depths and health and productivity across that larger Borrego Springs mesquite bosque habitat. You'll also notice that the high and moderate productivity at Borrego Springs in yellow has been consistently declining between 2019 and 2024, whereas the CDL mesquite bosque has remained incredibly stable. So this is a really good sign that this is due to groundwater declines, which have been happening much more rapidly in the Borrego Springs area compared to Clark Dry Lake. So now moving into the potential adverse impacts. So to get a long-term analysis of mesquite bosque health, I had to switch data sets. So in this analysis, I used Landsat, which has a 30-meter resolution, which is a bit coarser, so you can't see an individual mesquite tree in this, but you can see several mesquite trees in 1 pixel. And we focused on the dry season from May 1st to June 30th. Which is the driest season in Borrego Springs, when mesquite are most likely to be accessing groundwater. And the one benefit of the Landsat imagery data set, although it is coarser, is that it's the most comprehensive long-term data set that it exists. So you can go all the way back to the 1980s and analyze the mesquite bosque habitat. So that's exactly what we did. So looking at the long-term trends, this data set starts in 1984. We analyzed 1984 to 2015, and sadly, we found that only 1.6% of the mesquite habitat has improved. And that's shown in blue. There's very few of it, but there's a little bit around the Borrego Sink, and I'll point out this is the wastewater treatment plant there, which is doing really nice. So that mesquite has improved, which is nice to see. That's really important. Now, only about 15% of the habitat has remained stable, and that's shown there in the beige color. And then sadly, 83% of the habitat has declined, shown in red. So these are some scary photos, but on the left, this is what it looks like when you have unhealthy mesquite trees that have died or declined. So this is what a lot of that dark red area looks like around the Borrego Sink. And these are found in the areas with the most drastic groundwater decreases. And they're also found in the areas that had some of the highest levels of human disturbance. So this is around the residences, roads, and different areas that had agriculture near the sink. So these areas don't look good. It's sad to see. But the good thing is that there's still quite a bit of healthy mesquite out there, shown on the right. And this is found in areas of stability or improvement, and some of these have slight declines, because decline doesn't mean it died. It just means it was a little better before. So some of these are pretty strong declines over here. Other of these are still doing good. Now we then analyze the SGMA implementation period, which starts in 2015 and runs to present. And when we rerun this analysis, you can see that 12% of the habitat has improved, which is a little better, and it's shown in blue there. Again, largely around the Borrego Sink, where groundwater is closer to the surface. About 61% of the habitat has remained stable, which again is good. This means that the mesquite that's alive and well is still alive and well. But unfortunately, we still have about 27% of the habitat that continues to decline. So what we can tell from this is that most mesquite decline happened before SGMA was enacted. But about 27% of the mesquite bosque habitat is still continuing to deteriorate, which is a sign of sigma undesirable effects. So that's not good. These are protected by sigma, so we don't want to see any impacts during sigma. So before I end on a really depressing note, I'm going to remind you that despite ongoing decline, there's still a lot of mesquite bosque habitat that contains really high quality, high productivity mesquite. That's about 670 acres. That's still doing just fine. So the conservation of these high quality areas should be top priority so we don't lose any more important habitat or wildlife. And a really big part of that conservation effort will be sustainable groundwater management. So it's really important that we start getting those minimum thresholds in and we start analyzing different trends in groundwater depth to make sure that this habitat stays around for the long term.
All right. Now we'll wrap up with some management recommendations. One of which, of course, would be to designate the mesquite bosque GDE as a beneficial user of groundwater. And just to be clear, that's the 1,850 acres that we've mapped and identified through several lines of evidence that should be considered as a GDE under Sigma. The conservation of high and moderate productivity mesquite. We emphasize the conservation of the mesquite that's already doing particularly well, as this is a strategy to maintain as much of the higher quality habitat, particularly for the associated flora and fauna, as we can. Minimize soil surface disturbance in the mesquite bosque habitats. So one way that you can minimize soil surface disturbance is to reduce or minimize off-road driving in areas of sensitive habitat. This is a great way to minimize erosion. And then, of course, we recommend implementing strategies to improve groundwater levels, particularly in the area of the mesquite bosque GDE. So just to return back to this flow chart that we started with, we have completed steps 1 and 2 as a part of this nearly 3-year project. And steps 3 through 5 are now passing off the best available science to the water master and interested parties in order to use that science. So I just want to thank you so much for being here and remind you that there's a poster session to follow. So Nikki, Travis, and I will be back by the posters over there, and our wonderful capstone team will be leading some of the posters, particularly related to the fauna. And then, of course, Dan is going to be back there with the riparian specimens. Very exciting. And with that, we will take any questions. Don.
Looking at the changes in the health in the seed bog, I mean, that's really 83%. Those are all really big numbers, very significant. Did you compare to the health in the ski boss in Clark Lake Valley? Because that can be the standard. I mean, has it decreased 83% out there, or did we look at that?
Sorry, I'm turning my mic back on. Yes, that's a great suggestion, and I have looked at that. So the analysis covers both areas. I didn't report the numbers, but Clark Dry Lake is much more stable. You see that a little bit in the higher resolution data that I showed from 2019 to 2024. So there's a small amount of Clark Dry Lake that does have decline, and it's mostly concentrated on the area that's on the far east side, which is along an area where it's mostly mesquite dunes. And I think that the mesquite are actually getting buried over time. So they appear less green. And we see there's like very slight groundwater declines in Clark Dry Lake, but not very much. You actually took us out to the well there, so you know very well.
1 feet per decade.
Yeah, 1 foot per decade. So very slight, maybe climate change related declines there, but we don't see declines in the mesquite habitat. A lot of it has actually improved. So I can report those numbers, maybe in our update. That'd be a good idea. That's a great suggestion. And thank you for all your help with the well monitoring. Yes, go ahead.
So the imagery at the bottom of the aquifer, I can use LiDAR data. I haven't really seen that come up yet.
Yeah, so my analyses do definitely not go that deep, but California Department of Water Resources recently hired a team who did airborne electromagnetic surveys, AEM. And we actually have those in our appendix. So if you look at our report, you can see some of the data. And that does go quite deep. I don't know if it goes all the way to the end, but it goes incredibly deep, like hundreds of meters below the surface. But yeah, it's quite deep near the Borrego sink, I can tell you that. And it tends to be shallower near the mountains.
So you could like figure out the water flow that would affect those things. Potentially, if you could figure out how it all interacts.
Yeah, that'd be complicated, but it would be possible. The aquifer in Borrego Springs is unconfined, which means it can move freely between these sediments. So that'd take a smart mind, but someone could do that. I don't know if that's me. Yeah, a good model, yeah. Yeah, John, go ahead. Okay, Bill.
You think there'll be any future threat from development at Rams Hill in the Bosque? They're planning a lot of building.
In the Bosque?
No, Rams Hill right above it.
Okay, yeah, I'm not super familiar with where Rams Hill is located. But yeah, we can see that development, building roads, significantly impacts the mesquite trees and negatively. And that tends to be how it is for all of the environment. So any development tends to fare poorly for any wildlife or vegetation. But yeah, I would have to look exactly what their plans are, but hopefully there's some limitations and conservation around the mesquite bosque. John?
Has, we talked about water levels and water quantity. Does groundwater quality play anywhere within the equation?
Oh, that's a good question. Do you have an answer?
Not that we've assessed. Yes, I think that could be an interesting avenue, but we haven't looked into it yet, so.
Yeah,
maybe
there
the
is
next area.
data on water quality. But I don't, yeah, we haven't looked into it, and I think they've said so far that the water quality is okay, because that's what everyone's drinking in Borrego Springs. But we'd have to look into it.
And comparing also to Clark Lake Valley.
Yeah.
Because that gives us a baseline over there too.
Yeah, that's a great suggestion.
I think it's also interesting to note that some of the mesquite bosque has been stewarded by people who have private ownership with small residencies in there. We know a couple of those folks, and they've actually seen they're very, with the overdrafting of some of these areas, and the drop in the water table, they've lost tremendously old mesquites, and so therefore it's actually adversely impacted. In some cases, the development's actually adversely impacted by the loss of this, this habitat on those properties. Where they once had, beautiful, very large mesquite trees and lots of wildlife, birds, it's now a wasteland out there.
Yeah, that's a really good point, that the mesquite bosque provides ecosystem services to human beings in the community of Borrego Springs, including beauty. The mesquite, when they look good, it's really nice out there. You get shade, it smells good too. It smells super sweet. You get wildlife, you get birds, you get insects, and your property looks better. So there's a lot of value in keeping the mesquite healthy. So thank you for your comment. Yeah, we'll go ahead and go in the back there.
In one of the slides, talking about the baseline that we established from 2015 onwards with the same one, and you showed 27% decline. You have an idea of approximately how much the water level fell for that 27% decline?
And do you have that number off your head?
It's variable by well, how much that's declined. So the two wells that I pointed out, MW5A, that was about 5.5 feet per decade. And then MW3 was about 20 feet per decade. And those are actually across the 8 wells that we examined for that analysis. That was the lowest end and then the highest end of that range of decline.
So is this a valid takeaway? Like, if the groundwater declines at a rate of somewhere between 5 feet to 20 feet per year, that decline is higher than what the mesquite growth can sustain to tap into the water. Is that, I'm totally making that up or?
No, you are
something
absolutely
that-
correct. Yes, so there's a rate of change. Mesquite aren't magic, unfortunately. It takes time to grow roots. And the interesting thing with trees and vegetation is when they start focusing on growing roots, they usually kill off the top parts of them. So that could be some of the decline that we see is that as groundwater drops, they're trying to grow deeper roots and access it, and they lose some of their top biomass. But yeah, you're totally right that the rate is important. It's not just the level, it's the rate of decline. So if things drop really quickly, mesquite can't catch up. And unfortunately, the groundwater doesn't usually rebound and come back up and help them out. It just keeps declining. So a rate of change could have caused a lot of this decline that it just, the mesquite couldn't keep up with it.
Then I wonder if your study can be used as a baseline, and if from here on, that there is some possibility of running a long-term like assessment of the rate of decline, would that help in terms of like assessing, are we doing more harm more rapidly, or is there any hope of like maintaining a sustainable, the 640 acres of moderate health mesquite, will they, like, is there any like thought along those lines that would be like future studies?
Yeah, you bring up excellent points. It's not just the magnitude of change, but it's the rate of change. And I would love for you to read our report because I think you'd have a lot of great insights that we could talk more about. So yes. Yeah.
Will you be sharing your report? That would be great.
We do have a link. It is on the reserves website, right, Seiko?
Correct.
Yep, so that's available now. So it is something that we have shared a little bit more limited in terms of getting some feedback from those involved. And then a final version of that is going to be available on the 15th of May, but you can see the current iteration of that on the reserves website right now.
Really great work, very eye-opening. Thank you so much for sharing.
Yeah, thank you. Tammy?
Wow, there's a lot.
The health of the trees, you assess the level of new tree growth. I'm convinced that I am firstly convinced the mature trees are into the groundwater, but I'm concerned that new trees won't ever be able to reach the groundwater. And therefore, if that's true, it's really just a long-term plan that we're gonna lose by natural death trees, old age, we're gonna lose these. So if you looked at new growth,
I love that you brought that up. Travis and I were talking about that this morning. It's one of my dreams to do a demography study of the mesquite bosque to try to understand the levels of recruitment and then the areas of highest recruitment so that we could create some kind of map that indicates where you're seeing the greatest natural recruitment of mesquite trees and then areas that might be ripe for some active restoration and planting of mesquite seedlings. Do you have were you raising your hand, Travis?
So when you're done, I have a comment.
Okay, so yes, Tammy, this work, I did not have the capacity to include those types of analyses, but I'm really excited about that kind of work because that's what keeps me up at night too, is that the mature mesquite are connected to groundwater, but those seedlings are not being able to put down roots that are able to connect to groundwater. So we don't know the answer to that, but just know that it's on our minds. And then I'll turn it over to Travis for his comment.
I mean, it's a very good question. I mean, the first question is, can we save the patient? Right?
Yeah.
And then we worry about getting them out of bed and living again. And so understanding mortality is sort of the first cut. And the second is to understand births and recruitment in the system. And that's part of the management, conservation and restoration plan. But I think there's good opportunity because Nikki, you pointed out that there was quite a bit of agriculture throughout what we think of as the bosque, especially moving towards Airport Road, in areas that have pretty good depths of groundwater. I mean, they were tens of feet probably historically, and there was mesquite there now. So that fell into that agriculture, there was likely natural recruitment of mesquite into those areas. So it's not outside the range, a lot of possibility that mesquite can, traverse couple tens of feet from seedlings to adult tree and have access to groundwater. It's not out of the range of possibilities.
Would you envision having to help that process out if you put new propagated mesquite in, would you maybe deep water those for a few years?
You just like getting Laurel all excited. She's like, this is the stuff she thinks about all the time. Yeah, I think that, you know, like assisted recruitment is a real opportunity, whether it's flooding, whether it's watering, whether it's, you know, planting plugs. I mean, you could plant, and you could grow a little mesquite in 3-meter columns and plug them into the ground. I mean, there's all kinds of opportunity, I think, for this. And I think all you have to do is look at the wastewater treatment plant. The density of trees goes up every year. The health of those trees goes up every year. So a little bit of augmentation can recover habitat in a really meaningful way. So I'm an optimistic person, right? I'm the Pollyanna.
I think you had your hand up as well.
Yeah, just talking about what Mark was saying about recruitment. Often in these systems, we need at least back-to-back, if not 3 years of good rain years in order for establishment. So with the unknown changes in the climate, it appears that it's projected that we'll get less of that. So.
Yes, an important consideration. I think you had your hand up first.
I have a practical question from a non-scientific mind. We're being told as residents of Borrego that the water's fine. We're okay. We can develop, or it can be developed, different properties. We can do this, we can do that. Don't worry about it. We have the water. Then I hear this and I'm like, wait a minute. Maybe yes, humans think we have the water, but what are we doing with our environment? So I'm a little concerned. I know this is going back, I assume, to the water master.
We're
Right?
presenting to them next week, yes,
But-
and they've been kept in the loop.
But it's scary for me is when I get told, oh, don't worry, there's water to develop it too. I mean, I ran said, oh, there's water to develop this, etc. When there isn't, if you look at this, because obviously we're drafting the water. So I'm just curious what's the next step? I mean, what is the next step? Practically, what are we gonna do about this problem? Besides go, oh my God, and wring our hands, and what are we gonna do? And let's hope we have, I'm the opposite of you. Not at all. And it scares me because, like,
Said you're honest.
well, which is so beautiful about this scares me, and I go up, we go out to, we off-road out, we stay on the road, don't worry about it. But we stay on the road, but I see this being decimated out there. And then the mustard is taken over and all of that. So really, what are we as a community gonna do about it? And what are we gonna, you guys are giving us great information and it just frustrates me because we have water, don't worry, develop. So that's my concern. And I know the park's also involved. I see a number of park staff here, resource people, so they're concerned. We're all concerned. So I just, I'm not very good politically. Do you hear that, John? Okay. We share your concern.
Thank you for your comment. And Travis, I saw you walk up. Did you wanna say something? Okay. In terms of a practical next step, I think an important part would be to convince the powers that be that the Borrego Sink Mesquite Bosque should be included in the groundwater management plan as a groundwater dependent ecosystem. And then that means reconfiguring the water budget to include an allocation for the Mesquite Bosque. So that's a practical next step in our mind.
That's what's going in the water district, not the water district. The water master, maybe it is a water district. The water master, sorry, Kim. The water master, that's his decision or their decision?
There, yeah.
Well, no.
No.
I don't think it is their decision whether there is a GDE or not. In fact, I think that I'll say this out loud, don't shoot me, Jeff. But, we have a public entity that's governed by festival rules of ethics and how they run, the water district, which is a member of the water master and is part of the lawsuit and the stipulated judgment. And they're now in possession of information that they know contradicts the GSP that was just approved by the state of California. And I think they have an obligation to take that to the court and demonstrate that the GDE was left out of the planning process. So really it's the judge who's gonna say there's a GDE. And then at that point, Sigma will guide what happens next, which is a lot of the criteria that's being laid out there. So, so it isn't, so there is really, the decision is in the hands of someone who will educate it. And then it comes back to the community though, because the community still is gonna set standards based on values. Like we can only deliver you data, but you're the one that says this much ag, this much natural lands, or this much golf, this much natural land. You guys are the ones that do that. And if the water master is not representing your values, you need to let them know. They don't represent your values.
Thank you for providing that
again,
nuance.
Don't kill my interpretation.
And Travis, may Zoomer make a comment or a question?
It's Diane Johnson.
Hi, it's Diane Johnson. I'm sorry, I wasn't able to be there. So
Just a second, we've got a comment over Zoom. Go ahead, Diane.
Oh, okay, thank you. So both this presentation and any comments from people here individually should be put on the Sigma portal that Department of Water Resources runs. It's the best place to be sure that something will come to their attention. I was just assured a few weeks ago that DWR has to keep an eye on that portal and respond and read all the comments and respond. So if you just Google Sigma SGMA portal, you'll find it right there. And we're considered an alternative GMP, so you pick that tab, and then you'll see Borrego Springs at the top of the list, and there's a little doodad on the right for comments that you can submit.
Can you see the portal?
I wonder if we would be able to put it on in our document or on the reserve website so that you could just easily click a link. So we'll be sure to update that and provide that. Thank you, Diane.
Okay, you're welcome.
Oh, that's a question whether it's possible to monitor the decline of the aquifer on an annual basis and compare that to the water pumping that's taking place. The decline in water pumping is fairly recent, and it's also and the amount that's pumped has dropped quite a bit. To see what that's doing to the groundwater, to the water table, and then to try to do a projection through 2040 at the current rate and see where the water might be, and then whether the mesquite could live or not be part of that question. And then to use that as part of the decision-making process, like how fast or how slow might it be, and could that influence, the health of it? Can that be done?
Yes. Yes, and it's actually one of the management recommendations that we provide in the report is going through these different kinds of pumping scenarios to see how that might impact the mesquite boscape. So
do you have it for that period from 2015 to 2025 on an annual basis in the box? Good.
And if you go to the Water Master website, which is on the Borrego Water District web, go down to Water Master, and all of their reports are contained in there, the charts. And it's the pumping is actually projected ahead, I think, for 2070, not just 2040. And I'm on the Water Master. I represent the community. So I'm hearing everything, and I have been hearing things for years. I was one who called for GDEs to be reassessed because the original plan just brushed them aside and looked the other way. And I said, you know, this is not what I understand mesquite biology to be, with roots, in my mind, 150 feet deep. I've heard that for 30 or 40 years, where they came up with 15 feet in the original plan. Was very convenient to some pumpers, but it had no basis in science at all. So we have a big challenge ahead of us to implement these management recommendations. And we have a technical advisory committee, which is made up of mostly PhD hydrologists and hydrogeologists, representing the county, recreation, which is golf, farming, the community, and the water district. So we're looking at 5 different interest groups, really, that we try to represent all the pumpers. And nobody's lying to you. They say there's plenty of water. That's projected ahead, and that's for we the people and small businesses of Borrego. That's not, I think what I heard you say was all the water we need and all the development. That means not all the development that's desired is going to happen, or can we allow it to happen? Because you can buy up farmland, which has been done. I'm very happy with that. But that doesn't mean you can take an equal amount of water and go use it somewhere else. It means that's money in the bank. And now we have to reach sustainable yield. The amount of water comes into our groundwater cannot be exceeded by our pumping. And including the entire aquifer. And we just went 10.5 months, at least at my house, which is right down the road, with 0 measurable rainfall. So, and I think I sit at 1.99 inches right now. I think this station here has even less than that for the last year. You cannot continue that kind of a drought situation and have a nice rosy sustainable yield figure that we use as a target. We're going to have to change with the times and with climate change and pretty drastic changes in our weather pattern. You know, we may get severe drought. We may get 10, 12 inches of rain in a year, but we have to prepare any eventuality. So my number is in the phone book, the little blue Optimus phone book. If you have any comments, please feel free. I've had my number in the Borrego before. I see you folks around town all the time. We're colleagues and friends, and we have a lot of respect for each other. And say what you want to say what you need to say. And I think it's very concerning. I love this report, the fact that you've dug in so deep and you've got such refined data. I think it's tremendous. I read the whole report, 241 pages. I didn't fall asleep.
That's impressive.
But the consternation is, okay, we have to turn this into reality. There's no use having a water district and having a water master and having community meetings if we're not going to take action. This is our town. We love the quality of life that we have. We want it forever and for our kids and future generations. So we're under obligation to act, not just nod our heads. And as you said, so many of these reports, you work so hard on them and they get put on a shelf. And then they always call them living documents. Well, they don't live very long up there on the shelf. we have to get off our butts and take action. So thank you.
Hey, Laura.
David?
I just wanted to say, I share your concerns. There was nothing magical about 2040 being the year that we have to get to sustainable. There's always been the question of how much water is there and are we going fast enough? And one of the things that they were telling me in the beginning when they were putting the groundwater management plan together was that it was going to be based on a principle of adaptive management. Meaning as we find new information, then we have to adapt the plan to whatever that new reality is. And that's what Mark's talking about. And that's what this study is providing us, is new information so that we can adapt the plan. At least that's how it's supposed to work. It may require all of us in this room pushing for that, but that's how it's supposed to work. And to that point, you're talking about minimum thresholds. And I'm just wondering if the information that we have so far, the data we have so far, is sufficient to provide recommendations about minimum thresholds, both in terms of depth to groundwater, but also in terms of rate of change of depth.
Yeah, we can provide kind of a first pass at that. I think that through conversation with the folks who are going to be visiting the report iteration that we currently have, there may be some adjustments to those before we feel comfortable settling on a final number. But the data exists to be able to create that number. Absolutely. Yeah.
So that's important information for the decision makers in this situation.
Right.
I would also like to add that I've been working with John Peterson since 1982 on this water issue in Borrego. And in the early days, I call it the A word. We couldn't even mention the word agriculture, even though they pump 70% of our pumped water. So today, it's all on the table. We speak freely. They've done a lot of hard work coming up with this stipulated judgment. We have meetings every month, twice a year in person. I think we have one this month in person next week.
April 16th.
And mostly on Zoom. And there's not a lot of fist fights or bloody noses. The hard, ugly fist fight stuff is in the past, and we can speak freely. And we've made a lot of progress. Last year's pumping was less than half the pumping figures from, say, 15, 20 years ago, where we had 24,000 acre feet a year pumped. Last year we had, before 24, we had beneficial rain, which meant a lot of the golf courses and farms curtailed pumping. We only had 10,500 acre feet pumped. This year we'll probably have more, but we're on the right path and we're making progress. But you should be concerned and you should be vigilant. Don't let the guard down and don't let the pressure off.
Thank you, Mark. And I think that's actually a great place to leave it. If you have any other comments or questions, please find us at our posters. Thank you.